We're doing matrix equations that involve scalar multiplication. Equation, meaning we have the equal sign. Scalar, meaning that we have a multiplier now. Okay, so in this case, we'll go ahead and just do like we've always done, which is we're trying to get x by itself using reverse operations. So we'd always want to move everything that's not attached to x to the other side first. So I'm going to go ahead and this is adding this matrix. So we will subtract the 3 by 3 matrix to both sides. So negative 1, 1, 0, 8, negative 5, 9, 4, 3, negative 1, negative 1, 1, 0, 8, negative 5, 9, 4, 3, negative 1. Okay, so that's going to cancel out the one on the right. Sorry, the one on the left gets canceled out, turns it into a 0 matrix. And then we'll go ahead and look at what we get on this one. And then, like I said, I like to make this a plus sign by distributing the negative sign through everywhere. And then that's just a little bit easier in my brain that I'm just adding these instead of keeping track of the subtraction the whole time. So that makes that up. And notice I got a different color here that helps me keep track of it. So on the 0, I'm just going to leave it off. It doesn't apply to the 0. I don't want to throw myself off at all. Everything got distributed with the negative sign, and so that's now a positive. So I'm combining these. So now I have 3x on the left equals this 3, these combination of matrix combined to be 11 plus 1 is 12. 4 minus 1 is 3. 9 plus 0 is 9. 2 minus 8 is negative 6. Negative 17 plus 5 is negative 12. I'm seeing a pattern here. Negative 9 and 0 make negative 9. Negative 14 and negative 4 make negative 18. Negative 12 and negative 3 make negative 15. 5 plus 1 is 6. Notice that everything here is divisible by 3. That sort of makes sense. So we got one last step. Our last step is going to be to get x by itself. What keeps x from being by itself? It's the multiply by 3. What's the opposite of multiply by 3? It's a divide by 3. Or you could think about it as a scalar of 1/3. So I kind of like that idea. I'll go ahead and not 1/3. Okay, so I'm going to multiply both sides by 1/3. It would multiply to the top, so it's 3 over 3. Those reduce. And then everything over here has that multiplier of 1/3 to it applied. Okay, so my final answer is x equals, and then I'm just dividing each element by 3. So I'm multiplying each element by 1/3, or basically I'm dividing it all by 3. You can also look at it as everything had a 3 in common here. I can pull a 3 out, and then those would reduce out too. All right, so, but this is just the 1/3. That's a little bit easier. So if you don't have a common factor, this is how you would do it. It can be done every time, no matter you have a common factor or not. Okay, so our final answer is 12 divided by 3 is 4. 3 divided by 3 is 1. 9 divided by 3 is 3. Negative 6 divided by 3 is negative 2. Negative 12 divided by 3 is negative 4. Negative 9 divided by 3 is negative 3. Negative 18 divided by 3 is negative 6. Negative 15 divided by 3 is negative 5. And 6 divided by 3 is 2. I just want to confirm my signs. I don't want to make a mistake with my signs here. Positive, 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 yes. Negatives, negative, and positive, yes. Got it. Okay, so the key is use reverse operations as we normally would. And then if we have any scalars that are kind of floating around, we use kind of like a reciprocal idea to get rid of that scalar. It's just like dividing, but we kind of want to stick to the scalar aspect of it. Scalar meaning a scale factor, factor meaning multiply. So we kind of look at this as a multiply problem. See if the next one's any different. And so I'd subtract this one from both sides and divide everything by -2, or multiply by -1/2 in that case. So yeah, this looks exactly the same.